Vladimir Iglovikov, thank you so much for being here.
Thank you for inviting me to this podcast.
Very good. Vladimir, today we're going to talk about computer vision, artificial intelligence, the state of the industry, the good, the bad, the ugly, and what is really happening beyond the hype in all of these fields. And I want to get started with the basics. What is computer vision in simple terms?
Let me try to describe it. I don't know how simple will it be, but think about this thing. So when you digital camera, your cell phone or something else is taking picture of the surroundings of yourself as a selfie or something else, it records it as a bunch of digits. It's called like RGB, red, green, blue, 3-channel images. And let's say you're familiar with this resolution, like 1000 by 1000 or HD or 4K or things like this. Basically, it takes as an input bunch of numbers. Yeah. But we are not interested in these numbers. We are interested in what is called semantic features. We would like to know that there's a person there, like a dog or sky or something like this. So we need some way to map from this raw data, this intensity, light intensity values, color intensity values on one side, to something meaningful that we as people and like maybe some other algorithms could process. So computer vision is science or maybe discipline that focuses on how to map raw values to semantic features.
Very good, very good. Now let's talk about what's the significance of computer vision in today's technological landscape and its potential impact on various industries.
Let me just probably give examples of computer vision that we face every day or think about it. Example number one, probably many of people here use iPhones and they have face recognition feature. So it is exactly this, it is exactly computer vision. What is happening there under the hood? We take selfie or maybe small video on the iPhone of our face, and it's a bunch of just color intensity values. Then computer vision algorithm need to identify if there's like face on it or not. Because if there is like no face, no need to go further. It identifies face. After this, it compares this face, and it's again another computer vision algorithm of face with face in the database. So you need somehow like to have a way to say that this is John and this is John, even like one has beard and another does not, and this is Vladimir and things like this. You need to compare. And after this, iPhone does another algorithm. It basically needs to identify that it's not like a fraudster and this is a real person who's sitting in front of taking the selfie and not just like photo of this person. So you see in this simple feature that we are using every day, face recognition in our iPhone, there's a bunch of computer vision algorithm. What can be done? Let's say Apple uses it for different things. When you take an image with your iPhone, you think it's just, okay, pixel values, things like this. What's happening under the hood in modern Pixel and Samsung and Apple phones? It says, okay, this is person, this is background. We see, and computer vision algorithms say, okay, background is a bit too light. Let's make it slightly darker. Let's make features on the face more pronounced. And it does all this post-processing on the fly. And we get pictures that are really more appealing, better looking, things like this. And this is happening not because we have better lens, it's also important, but because there's some post-processing involved. Way that people, let's say photographers, post-process their data in Photoshop to make it look better. Computer vision does it on the fly algorithmically. It can be this way. And okay, document scans. Right now, Dropbox and other things, you take some document, you take a picture of it, and then it is, okay, it's not just a bunch of black and white dots, so some image text, it's written here, written there, it's another application of computer vision. So if you think about computer vision applications 10 years ago, it wasn't, people were experimenting a lot. Technology was already there, but it was immature, and it was before what we call right now deep learning revolution or AI revolution that's happened in the industry. But right now, computer vision became so mature that list of where it's used, face recognition, working with satellite imagery, forensics, medical imaging. Basically, if you say word image or think about image and any industry, you have computer vision algorithms there. It's everywhere. It's like electricity in some sense, and it is spreading across the world.
And we keep going back to numbers and algorithms that are interpreting those numbers to understand what they really are and tagging what they are seeing. And I know I'm saying that in the incorrect way, right? But am I getting that right? It's digits and then algorithms that are,
you're definitely getting this right. Yeah, we're getting raw numbers and getting some labels or some, yeah.
And AI is helping accelerate the way that we label more and more complex set of numbers, and the way that the programs can learn how to label the numbers. That's where AI is like bringing the game to another level.
Okay, first of all, let me clarify a bit about notation. As people say in industry, if you write these algorithms and you use like languages like Python or C++ or something, you call it machine learning. If you talk about this in PowerPoint, you call it AI. So in this sense, I mean, machine learning and AI these days, they have exactly the same meaning, but machine learning is a technical term and AI is a way to raise more money, bring more hype, things like this.
Right.
I may use this word interchangeably, but personally, I prefer more technical and more accurate like machine learning because that's what it's actually doing. And your question was, does this development in machine learning algorithms help us to extract more advanced and more nuanced and more valuable insight from the data? This is definitely the case. First of all, for all this time, we were getting these insights from the data. As I gave in this example, you get a picture of some document or book, and it gives you text back. So it was good, yeah. And it's getting better. Like we improve quality of this. For example, early in the days, you give text and it returned to you text. Right now, there are some scientific works and even open source models that do the same with mathematical equations. You see, it's a bit like a next step because more complex. And we are working with blurry images, an image that missing half information. It's getting more and more advanced. Yes, again, face recognition. If you think about this algorithm, again, described a few years back, it was like one mistake out of 10,000. Right now, these modern algorithms, they incorrectly may identify your face, including people that are very similar to you, one out of whatever, like 10 or maybe 100 million. So the accuracy is pretty insane. Again, if you think about military applications, I don't know, don't have insights to it, but I suspect that it's also advancing there because a lot of ways to improve accuracy and decrease cost of the weaponry. So yeah, algorithms are becoming better and better. Pace is accelerating. I remember I was coming to this like main artificial intelligence, use artificial intelligence here, conference called New RIPS, and it has 3,000 people. And then in 3 years, it had 14,000 people, not just people attending it. It's people who are publishing papers there, from universities, creating state-of-the-art models. And next year, I didn't even go because I didn't like, I need 50,000 or something. It's just a bit too much. Pace of this is accelerating, and it's accelerating in terms of how good our computer vision and other algorithms are on one side, and also how much they are used to solve actual problems, to bring value to actual people. Again, I remember this, it was not that long ago, in 2017, 2016, when I moved to this area, computer vision reminded me teenage sex. Everyone was talking about it from all these news outlets. We beat human performance here, human performance there. And I was looking for a job in computer vision. And I talked to hundreds of different companies. And everybody said, like, we would like to use it, but we don't use it yet. So yeah, everyone was talking, but no one was really doing. Right now, Situation is similar with large language models. Everyone is talking about ChatGPT, generative AI, things like this. But when you talk to people, do they actually use it in production for values? They say, we would like to use it, but this time didn't come yet. We're exploring this. But yeah, but computer vision is mature. It's already used. It's already making millions and billions to all these different companies around the world. It's mature technology.
Vladimir, what is your journey in the field of computer vision, and how did you came to be the founder of Augmentations AI?
Machine learning is a pretty cool field. That if you talk about physics, you may find people around who are experts and veterans in physics, and they're whatever, like 70, 50 years old, and they're doing this for like decades and decades. Machine learning in its current implementation is so rare that world experts, they work on this machine learning. They started working only like 5, 7, 10 years ago. It's very new and very cool area. I started using in 2015. I graduated with my degree with PhD in physics. And I was thinking about staying in academia as a postdoc and pursuing career of professor, or maybe, looking for software engineering positions. At the time, I believed that software engineering is like for second-class citizens. It's just like below my level. Every physicist thinks like this. And I was like confused because staying in academia also didn't look great. I looked around, and my friend, and I studied at UC Davis, which 1 hour drive from Silicon Valley. It has huge impact on this because it's so close. My friend who graduated from our department a year before that, he came to visit us at UC Davis. We had beer, and he said that he works as a data scientist, and just like what this data science beast is, what it is about, because I like component about science there that software engineering title doesn't have. And he said it's kind of like another way to look at the world, not through experiment or theory or like numerical simulations as physicists do, but through the data, because data gives you a lot of insights, and data scientists is basically people who get insights out of this data. And I just like, wow, that's cool. So I went to the internet, entered word data science, and I didn't understand anything because it's a buzzword and thousands of different things could be attributed to data science. And I just, okay, I don't know what's going on. So I started taking online classes at Coursera about data science to get at least some understanding of just what does it even mean. And in one of these classes, they talked about this subset of data science called machine learning. Way that you train algorithms, not necessarily computer vision. Right now, they call it AI, how to automatically extract insights from the data, raw data in this structured way. And I decided, okay, this looks the most appealing to me. And I started looking for a job in this data science. It was 2015. I found a job. And for a couple of years, I worked with what is called tabular data, data that doesn't have this deep meaning, like not as cool as audio or texts or images. It was something about, just imagine you're coming to the bank and they're trying to tell you, should they give you a loan or not? And they have information about you. Age, gender, education, how much debt did you have before, and things like this. And you need to do some predictions. For a couple of years, I worked on them. But after this, computer vision became more mature and some tools appeared, and there was like a lot of hype around internet. And I started looking job in computer vision. I again took few computer vision classes, claimed that I'm expert in my resume, and started looking for a job. The issue was, yeah, as I mentioned, everyone talked about this, but there was no position. And finally, I landed a job at a company called Lyft. It's a pretty big company, valuation $3 billion. It's direct competitor of Uber in the United States, especially in San Francisco. And they formed self-driving division, and I worked there for a few years. So that's how I got this. About augmentations, the thing is because computer vision, even right now, it's a relatively new area, a lot of tooling, a lot of things that you need to create these algorithms to efficiently extract information from these images, they didn't exist. And for one of the subsets, for this like things called image augmentation, my friends and I, we just created this open source project, open source library, that solve this issue. We need it for ourselves, of course. We enjoy telling our friends how cool it is and making them to use it. But one thing led to another, and right now we have 1.7 million monthly downloads. People use it all over the world. All big and small computer vision companies are using it, but in many ways it became popular because, again, we created for ourselves, so we knew what we are doing, and at the same time, because field of computer vision is growing so fast, it pulled it up with itself.
So you were so excited about computer vision and the machine learning that's behind computer vision that you created a platform, a tool that enables you to go faster on training the algorithm, or training the basically aiding that machine learning and making it faster, right? You're creating a lot of images, a lot of data to feed and train the program.
Let me expand it. It's pretty close, yeah. So when you train any machine learning model, it can be ChatGPT, it can be computer vision model, it can be predicting should bank give you a loan or not. What it tries to do, it tries to memorize. And if you feed your algorithm one image, it will just memorize it, and that's it. You will give it another image, and its predictions of what it is depicted there will be garbage. But if you give this image 2 images, it will still memorize it. But if you give it million, it will not be able to memorize. What's called doesn't have enough capacity. It will look for patterns to memorize. In many ways, it's similar how we as people process the world. We create some kind of high-level abstract models of human as being something with one head, 2 heads, and 2 legs, instead of just memorizing. It's like as an image. So it is important, if you want to have a model that what is called generalizable, that doesn't just memorize your data it was trained on, but can reliably work on the data that it never seen before. We need to feed it with so many different diverse data that it will memorize patterns. ChatGPT is so good because it was fed on such an enormous amount of data that it understood and captured such crazy patterns. It's all happening automatically, algorithmically. But yes, so it is important to have big diverse data set. The issue is you always want more of this data. You're always limited. In some situations, because you don't want, in some situations, it can be easy for you to collect data. Let's say you scrape internet, and that's what many big companies do. But if you, let's say, work with medical imagery, luckily, people don't die that often. They don't have that many seizures. So you're very limited in terms of how many X-ray scans with some seizures or some issues you have. And you can't create more of them because it's just ethically bad. Also, labeling this data could be challenging because you need expert doctors. You want more data, but there are some problems about accessing it. And here there's like a hack or technique, if you want, called image augmentations. How to trick network, if you want, to think that it is absorbing more diverse data when you really have small. As an example, if I need to recognize human, I can take, let's say right now, screenshot of you and flip it horizontally. As a raw data, it will be completely different set of pixel values. But it's still human, and it's still human. So what our library does, it allows in a very creative ways, very fast on the fly, from a given set of images, generate infinitely more similar but kind of different. So for people, they still recognize you if you rotate your image or flip or do something about this. But for network, it's new pixel values, and it will be forced to look for patterns and not just to memorize it. Yeah, it was a big, long explanation, but basically think about this. Our library helps to generate more synthetic data out of the original one, and it is used to make networks more robust.
Did you ever think that augmentations was going to get as big as it is today? When you and your friends were starting and doing this open source code? Was it a small project in your mind and then it became something different and you were like, wow, a lot of people are using it? Or were you thinking this is going to be massive and a lot of people is going to be using this?
So when we created this project, none of us worked on this full time. In a way, it wasn't like this. You wake up in the morning, you go to the shower and you think, oh, what I'll do about augmentations today. No, it wasn't the case. No one was working full time. No one was dedicated to this. We did this because we wanted this tool. We did it for ourselves. And if you ask us probably at the time, do you believe that 10,000 people will use it? We'd say, yes, we can believe it. Would you believe that it will have 60,000 downloads per day? We would say, no, for sure, it just doesn't happen. You don't think in these terms, it's just a bit too much. So at the time, we definitely didn't think that it will become popular, especially because there were and are similar libraries from Google, from Facebook, and from other companies. They're just not as good, probably because these big companies never dedicated enough time or resources to develop them to the level that people would prefer.
And now that you've seen the reality of where you can go, that you've seen augmentations grow, that you're seeing so many people use it and so many downloads, when you think about the future, what's your vision? Where do you want to get augmentations to?
About this, I can talk about a bit better for sure. Right now, I work on this full time, meaning I wake up in the morning, go to the shower, and as I described, and I think about this, what I will do today, how to increase this growth, what are my priorities, what should I do today, what I shouldn't. In this sense, I do think about the future, about the library. Right now, we have, as I mentioned, whatever, like 1.7 divided by 30, or 55, 60,000 downloads per day. I did some market analysis and it looks like it's doable to get it to 1 million per day. And this I would try to do in the next year. And these are free users that use it and download. And again, download doesn't mean user. Same user may download it for different tasks 20 times.
Right.
It's one user, but 20 times. So it's not direct comparison like to users. There is no money involved. At some point in the future, probably in the next few months, I will add another flow to the story. So right now, library is free and people can use it for free. At the same time, every company in the world have problems with data, storing data, processing data, analyzing data, data security, things like this. And because augmentations is used because of the lack of the labeled data, you need to generate on the fly this synthetic from your original because you don't have enough original. And for this reason, I'm thinking, and I have a few ideas, will not share them right now, prefer first to explore and to get more structure about this, what could be built on top of it to be valuable for the companies that work with images in such a way that they would be willing and interested in terms of paying for the product. So right now it's not a product, it's a library, but there's some ideas how to build product on top of it. Product meaning people are paying for this and they find it useful. But yeah, this discussion or something will happen in a few months.
Are you having yet any discussions about companies that are interested in acquiring augmentations as a company?
There was zero discussions so far about companies wanting to acquire augmentations, partially because we, in our library, we have permissive license.
Right.
Everyone can create, like just download our code,
right,
probably rename it, and then build on top of it. In the sense, if you want to get access to our code, just go and copy it. It's available on the GitHub. But there were some few companies approached me about they would like to benefit maybe not from the library itself, but from the community and people who are using it. They would like to have some synergy and promote their products within augmentations community, or some other type of the thing. So it's not exactly acquiring, and I would not be interested in acquiring right now. Then overall in acquiring, I don't know. But people approach to see what type of collaboration and mutual synergy is possible. Again, some financial component could happen there, but I don't think it's big enough. So I didn't explore these options at the same time.
Got it.
Yeah.
Are there other companies doing similar things to what you are doing, and what sets Albumentations apart?
Okay, let me split it. Albumentations right now is not a product. It's a library. It's a tool that is used to create these synthetic images on the fly.
Okay.
There are many libraries, including, as I mentioned, from those created by Facebook, a couple of them, and Google and Microsoft, and made like few open source analogs. So they exist. Albumentations is just like the fastest, most flexible, most diverse. It was a big surprise to me because when we created this library, we assumed that when it will become popular, that due to this permissive license and everything, other libraries will just like copy our functionality and our insights, and I mean, everyone will get to the same level, but for whatever reason, it didn't happen. I don't know why. About companies. Many companies, I know like at least a few companies that were built on top of Albumentations. They raised few $1 million seed rounds and they're doing something on top of it. So this definitely happened. It's not direct comparison because they built product on top of the library. If we will go these directions, yeah, they'll be our competitors. But right now, I don't think about open source project as being competitors to each other, because people, I wouldn't say steal, learn from each other,
right,
and adopt practices from other projects. In this sense, yeah.
And the community that you are building, is that a community that is simply taking from Albumentations and using it on their own? Or is there an open source code mentality that they are also collaborating? Do you see collaboration coming from the huge community that you're building?
World of open source in many ways what people call is unfair. I personally use, I don't know, hundreds of different open source libraries, but I contribute to like report to them if and only if I'm facing some issue. If there is like some great library, meaning I don't have problems with them, I don't know who are the authors, I'm not paying them anything, and basically I don't even think about its existence. You start thinking about library when you have some problems. So for Albumentations, we have kind of like two things. First of all, if there is like some issue, and it may happen, people report about this issue at GitHub, and this is already valuable contribution. But they do it because something they expect doesn't work. They report, we fix it, and go forward. It's one of the contribution, and people do it out of necessity because they don't get what they expect. But there is another, which is also pretty cool and similar and closer to what you described. Many people would like to contribute to open source overall, including Albumentations. Reasons could be different. Some people, let's say junior software engineer, is looking for a job, and on the interviews is asked, do you have any practice? Could you show any project you worked on? And here he or she can say, okay, here's how I contributed to Albumentations. And if needed, I can, say, yeah, it was good contribution, things like this. I don't know about other qualities of this person, software engineer, but so far as I've seen, good enough to be considered. So it can be this value. Some people contribute because it's fun. Just imagine you spend few hours in the evening, you depressed, I don't know, someone broke your heart or something bad is happening in your life. You spend couple hours, you make contribution to Albumentations, and it affects thousands, I don't know, tens of thousands of people. You feel your positive impact on the world that you may not necessarily feel at work. Some people contribute because they would like to boost their skill. You have some skill as a programmer, as a software developer, then you contribute to any open source projects, including Albumentations. You get some feedback from more experienced people. You learn from other tricks and something from the code. It's a good learning experience, probably better than online classes, but kind of falls in the same domain. And basically, and there are also some people who just want to say thank you. This is probably my favorite. They use library for so much and they see how much effort we put into this. They see some small or maybe not small issue. They want to say thank you. They just create the fix, we merge it, and it's good for us, it's good for this person. So in the sense, there's a lot of people who contribute without having any financial reward for it.
Very good. What are the biggest challenges that computer vision as a field is facing today? Data, enough data is the one where Argumentations is helping on, right? So there's not enough data, we can help you there. What other challenges exist?
Data, I would say, is the biggest. And data could be because, again, as we discussed before, in hospitals, it can be hard to collect some rare cases. Or for example, if self-driving car is driving, it's pretty hard to collect data when it kills pedestrians. Because luckily it's not happening, but you still need your models to see that these cases should be avoided. That's how they look, things like this. So in this sense, some synthetic data generation is possible. Also, second problem is storage and versioning. So early in the days, let's say 10 years ago, when you're working with thousands of images, you can store it on your computer and it's not a big pain here and there. Right now, companies like Stable Diffusion, Midjourney, and others, and big tech companies as well, they work with billions of images. It's like terabytes of data, and you need somehow to have access to it. It should be fast. You need to understand how it's stored. It should be backed up. So it's like kind of standard issues that people have with the data, with normal data in databases, but on the larger scale, because images are pretty big and heavy in terms of how much megabytes they occupy. Second problem, but you see, problems with images are not very specific. The same problem exists with text and with everything else. It's like data, lack of labeled data, storing, processing, and all these database-related things, and of course, compute. NVIDIA is so expensive right now because everyone is trying to buy these expensive GPUs for this processing, and images are particularly demanding for this.
So for video, right? Because you're helping with images, is Argumentations helpful as well with video? How do you go from image generation to video generation? Is it just expanding on image generation, or am I getting into a completely different field here?
Okay, so video is a step up on tops of images because it has not only these spatial domains, horizontal and vertical, it has like temporal component. In 99% of the situations, you can treat video as a sequence of images. So in this sense, Argumentations even right now can be directly applicable to videos if you treat this video as a sequence of frames. And you can definitely affect them in a similar way and people use it, and this is valuable. At the same time, at the time when I was actively working on computer vision tasks at work, machine learning, competition, and research, videos were not a hot area yet. It's getting popular only in recent years. So Argumentations can work with videos, treating them as a bunch of frames, and each frame is just an image. But I believe there are important additional improvements that could be done on top of this to make video not just bunch of frames, but bunch of frames and something special on top. We didn't explore this direction yet. For this, I'm planning probably again in a few months to talk to companies that work particularly with videos and to understand problems that they're facing right now more. And maybe from these discussions, we create something special about videos.
I love it. Let's go back to you being a physicist. And we talked about the challenges that computer vision is facing, and we talked about data, labeling of data, storage, and then computing power. and so on, computing power, there's the dream and the future promise of quantum computing that is going to exponentially change the computing power. But I know it's kind of a headache as a physicist to get into, quantum computing versus, the as in the world of physics, it's just, it's mind bending. It's astonishing. What are your thoughts there? Do you believe that this is something that we're going to see in our lifetimes? Not. Why? How do you feel about that?
Okay, let's look at the bigger picture. First of all, there are a few things can we do even before quantum computing. Physics, when you think about physics, for thousands of years, physics were done through purely experiment. You go under the tree, apple falls on you, it hits your head, and you understand that apples is such a thing that fall from the trees and they hit your head. So some experimental things. Then somewhere in the middle of the past millennium, Newton and some other folks developed some theoretical approach to this. So we started exploring the world as it is through two tools, experiment and theoretical kind of analysis that gives it like mathematical structure, predictive power. Again, purely from experiment would be very challenging to understand that planets circle around the sun, but math kind of helped with this. Then it was going for new hundreds of years. In the middle of the last century, third tool appeared, computer simulations. Many things couldn't be approached directly with experiment, couldn't be done theoretically to complex math, but then numerical simulations. And this was going for another 50 years. So there were three tools. And right now, in some sense, machine learning and data science became a fourth tool in physics and other natural sciences to explore the world. In this sense, it was believed and maybe assumed that physics kind of stagnated in terms of generating new knowledge at the end of the last century. But with this creation of machine learning tools right now, they're like pretty interesting works and breakthroughs, because machine learning adds whole another non-incremental layer about approaching problems in physics. And this is good. So in this sense, I believe that machine learning has very positive effect on physics, and it's actively developed. On the other side, physics as a science it's very mature science. It's very developed. We understand our world in very tiny details. And so a lot of physicists right now go for machine learning job, similar to me, and they bring their knowledge to this machine learning. So machine learning may benefit and become more efficient here and there. So it's about physics to machine learning and machine learning to physics. Same could be done for chemistry, math, and et cetera, et cetera. About quantum computing. Quantum computing is a very powerful tool, I would say, non-incremental. It's not about making something 2 times faster. It's about, for some types of the problems, making things from impossible to being possible. Typically, people talk about this about cryptography, because there it looks the most feasible. There is some discipline called quantum machine learning. I didn't look into it because at this stage of quantum computing, it's a bit immature and early to talk about this. And even on the conceptual level, I understand quantum physics, I understand machine learning, but without reading through these materials or how do they were able to merge them, I don't even see they're so different that it's just hard to merge.
Right.
At the same time, because in the field of cryptography, it's able or promising to make impossible things possible, I suspect that if and when quantum computers, and they're improving, it's not abstract concept or extremely hard task as nuclear fusion that is technically feasible, but it doesn't look that we're getting closer. But with quantum computers, we have quantum computers. They're just too small right now. But as you know, from small to bigger, it's much easier to go than from impossible to possible. When it will happen, next decade after this, our lifetime or not, it's hard to tell. Optimistically, I hope it will happen, some breakthroughs in the field of quantum computing, its application to real world things, including maybe machine learning in the next 10 years. But again, we will see.
Okay. Thinking about the future, let's, I know it's super hard to think about the future, and if we have the crystal ball, we will be making millions with it, right? But in the field of computer vision, where do you think computer vision will be in the next 10 years? What advancements are you in your mind, you're like, this is going to happen, this milestone is going to happen? What is coming next in the field of computer vision?
I don't think that computer vision by itself will change as much, but right now there is a general trend which gives a lot of really interesting and cool things about multimodal machine learning. What does it mean? So right now, if you go to ChatGPT and write some text, it will give you output as text. If you upload there an image, it will give you something about this image. Or you can write some text and it will generate your image from this. So you see, it's not about text or about images. It's about these two modalities together. Think about us humans. We see, we get sounds, we touch something, and all this information together gets merged to us to give understanding of the world around us. Machine learning models, they're too specialized. One is very good about playing chess, second about playing StarCraft, third about recognizing faces, fourth about generating text in this chat. But general trend, and I believe again, it's like the most promising thing when we start merging them. Right now, we more or less kind of have understanding of how to merge images and text, but there's also videos, what is called point clouds, meaning like a bunch of dots. There's audio, things like this. So I believe that general trend for machine learning for the next decade or even so will be about making machine learning multimodal. And again, computer vision, you see, like, I don't know the number, but I suspect that 70% about information that we humans get around about the world, we get through our eyes. It may happen that in this multimodal approach, computer vision and images and videos will also be the driving force of this trend.
And how far do you think AI will go? Some people talk about, we can define artificial intelligence in many different ways, right? And today you were saying, hey, we could call it machine learning most of the times, but for marketing purposes, we call it AI, right? But some people are talking about artificial general intelligence, right? Where it starts just being able to learn on its own and have awareness of its own, et cetera, et cetera. Do you see that as being something that will happen in our lifetimes, or do you think it's more hype for press and marketing purposes?
Okay, let's give some overview. Typically, machine learning models are trained when you feed it a lot of data and it learns from it and life is good. But there was pretty good example of AlphaGo Zero, its work from DeepMind, some subsidiary of Google, where they created this model to play Go. They didn't teach it and train with any examples of how people can play Go. They just describe how the rules work. It is allowed to put this black stone here, white stone here, and if you get this pattern, basically you lose or win. And then they said, okay, now this AlphaGo Zero, without knowing how to play, meaning only knowing rules, but doesn't know like strategies or good moves or bad, it made it play with itself. From trial and error, one AlphaGo Zero playing versus other, and learning from itself. And I don't know, few million or billion hours of this playing later, it became proficient in terms of beating the best champions of AlphaGo humans in the world. So it was an example that you can learn from the data, and it is faster in many ways, but technically it is possible for this model, this algorithm, to learn from its experience. Is it conscious? No. Is it intelligent? I mean, hard to say, define intelligence, but was it able to learn from pure trial and error to the level of like that was impossible to humans? Yet, yes, it is possible. So it means that technically, even without consciousness or intelligence, as we think about human, some algorithms and devices can get to the level that unreachable but human beings at this stage of our biological kind of development. But if it was we able to do there, okay, let's think about ChatGPT. ChatGPT and similar models, when you chat with them, you, especially originally, you get impression that this is something conscious, intelligent, and it gives meaningful answers. I use ChatGPT to write code. I use it to brainstorm. Is it conscious? No. Is it intelligent? No, but behaves like yes. And so here you may separate this question. Do I believe that some consciousness will appear in these algorithms if they become more complex? I doubt this, but it's hard for me to talk about consciousness because at some point I went to this Vipassana meditation, got very excited about the consciousness and mind and things like this, read about 10 books about consciousness, how modern science understands it and tried to approach it. And the conclusion was we don't. Meaning it's so unstructured and unknown territory that I'm not even ready to go and do some conclusions. It's like completely flipping a coin. But do I believe that is it possible that some algorithm by some bad or maybe not careful guy would be created that is powerful, intelligent enough? And if this bad guy will give its access to whatever, like nuclear weapons or some other machinery or some guns or access to electric grids or something that affects human directly, and this algorithm not being conscious but being skilled enough may affect humanity on the mass scale in a negative way, it's possible.
Let's
I
leave it at
hope,
that. I
yeah,
hope it doesn't happen.
I hope that doesn't happen, but technically I can see this direction.
Vladimir, as a leader in the computer vision industry, what advice do you have for anyone that wants to get into this field or establish their own ventures?
Let's separate it. So if you talk about people, and many people are coming to the field of machine learning based on the hype about AI or because it's cool, as it was for me, and if they're coming to this like machine learning domain, what advice I'll give to them? Advice sounds like this. Unlike any other, so machine learning is not a science. So physics is a science, like psychology, technically, sure, let it call it science as well. And chemistry is a science, things like this. Machine learning, and you can ask this to any expert or non-expert in machine learning, is an alchemy. It's not structured. We know how to use, how to create these powerful algorithms, but do you understand like how they generate this text to recognize these faces? No, it's many matrices with some numbers and then multiplied on each other, and then you get face recognized. What's happening there? It's some emergent phenomena that we don't understand. In this sense, you see in physics, you study math, you do some experiments, you get some solid structure around the world, and this is the way to go. That's why I believe to study some mature, complicated science, it's better to do it in university with some mentors, professors, things like this. But if you talk about field of machine learning, which is not a science, but an alchemy, knowledge on how to create these things about tricks and tips about something, it's purely hands-on experience. It's more about how many hours you spend on training actual models, labeling actual data, and making your hands dirty. So this is the best way. Similar probably to computer science and software development. Before you start writing good quality code, you need to write millions of lines of bad quality code. So similar in machine learning. Don't like think they'll study and then do something. Make your hands dirty as soon as possible. An entry point to machine learning is pretty low. I mean, 10-year-old kids can easily do some face recognition models. So it may be more challenging for them if they were 20, but it's not the same as to getting to the age of physics. You need like to get PhD in it because you need to study so much. So for people who want to get hands-on experience, maybe find a job in this field, and they're pretty well paid. Make your hands dirty. No one gives a damn about your education in this field. Show how much can you do and what can you do. If you think about companies that would like to get more value or make more money in the computer, leveraging computer vision, because many companies, they have some imagery data for them. It can be, I don't know, faces or scans of the documents or just cameras or something else. There I would recommend to get advisor or maybe in-house person back in the executive team who worked on these problems before. Because with machine learning, people think, okay, machine learning, we need compute. Then you also need data, data storage, data labeling. You need some kind of machine learning engineers, you need them backend. And basically, you were thinking about this some small thing, but it's huge and enormous and big and extremely costly. At the same time, typically, machine learning gives you a very small amount of value. There are a few good examples, like again, ChatGPT or maybe Grammarly, where ML AI is the core of their product. But did Google worked as a search before implementing machine learning in their search? Yes, it worked pretty well. Did it become better? Yes, it became better. Did Facebook work before without machine learning? Yes, it worked. Was it a good product? Yes. Did machine learning added value? Yes, but it worked before this. So I hear pretty often, especially in the pitch decks of some people who like pitch me for investing in their startups, our product doesn't work, people don't use it, they don't find it valuable. But now when we'll add AI to it, everyone would love it a lot. It's horrible mindset. Just don't go this path and try not to touch machine learning if you don't have expertise or mentor or advisor who is there.
Thank you. And I love how you break down all of the answers. That's very helpful for the audience. Vladimir, one last question to you. What do you do when you are not working?
This is maybe not a good question. What I love about San Francisco Bay Area, not just that people, that you have these tech companies and you go to every Starbucks, you see like 5 founders there, or people is full of these ambitious, exciting people. San Francisco Bay Area is geographically located near the ocean and near Sierra Mountains. Outdoor activities, hiking, it can be water activities like surfing, kite surfing, wind foiling, things like this, are available. Mountains are nearby, amazing, thousands of hikes. I live in the Bay Area for 14 years. I don't think I ever made the same hike twice. It's just so many of them, so they're amazing. And it's not just me. Nearly every person of you, it's kind of, it's like in New York on Friday night, everyone is going to the bar. In San Francisco on Friday night, everyone like jumping into the car and driving to Tahoe for skiing, for something. What I'm trying to say, I'm kind of part of this trend, and I'm doing a lot of like outdoor activities. I lift weights during the week just to stay in shape, and in free time in winter it was skiing season. Right now it will be rock climbing and kite surfing season. Basically, I complement my mental, if you want, activities about working on augmentations with some kind of outdoor physical pressure on my body, because you can be pretty hardcore in both of them. And when you do one, you relax on the other.
I love it. Absolutely love it. Vladimir, this has been amazing. I appreciate it so much. Thank you for taking the time. Thank you for being so patient with me as I was asking the questions and trying to explain and make. I love how you make the complex sound simpler and the way that you can describe things that might get very complex in terms very quickly, but you bring them down to the audience, to me, to my audience. I appreciate you. I wish you all the best, and I hope we can stay in touch and do this sometime again in the future.
Absolutely. So thank you for inviting me. I hope I helped. Okay, have a good day.